You hear me now? So we have Daniel Wittenberg. Get that right? Look at that. He's going to be presenting on scaling Nagios at a giant insurance company. Dan has been a Unix Linux admin for over 15 years and a NetSaint/Nagios user for almost 10 of those. He's written many custom plugins and event brokers and also contributed patches and updates to many others. He's also an avid open source promoter and uses it whenever possible. So without further ado, here's Daniel.
Well, one of the first questions that people usually ask is how big of an install? Because I'm sure you guys have probably all seen the forums where people are like, oh, I have a large install of like 500 hosts. Okay. Right now what we're looking at is about 36,000 devices and about 1.4 million service checks. With the other updates that are coming, there's probably going to be close to 50,000 devices and over 2 million service checks by the first of the year, with some new labs and stuff that we're bringing on. So it's getting big fast. So hopefully we'll have some helpful advice. Some of the topics that kind of went through is some of the things that we've kind of addressed and looked at, kind of all the different areas. I thought I'd just try to hit as many of these as possible. Most of these we could talk all day on individual items on different things that we've done, so we'll try to kind of get through some of it as fast as possible, and if you guys have questions, just holler. I know some of the performance stuff has been covered in other talks, so we'll kind of jump around where needed. Here's kind of a rough architecture of what we have. We have let's see how this thing works. We have a custom control panel that we wrote that kind of manages the host configs, because all of our configs are, as you can see, it kind of pushes them over into Puppet. And so we needed something that wasn't centric to one single server. A lot of the options and off-the-shelf tools we saw, they assumed you had one server and you were configuring all your configs on that one server, where in our case, we're pushing it to a whole bunch of different servers all over the place. So it needed to understand, well, I'm configuring this service or this host, but this host goes on this specific server and this management server for a reason. So it kind of does some of the back-end work of figuring out which servers need to be put where the load is, so we can kind of pretty evenly distribute stuff across all the data centers. So we kind of had to write our own control panel to kind of manage the whole environment. It also does some interesting things, like you see it's got connections out to all the management servers. It can query using the live status interface to find out what a host is actually doing on the server. It does some various other checks of what the actual management servers are doing, so you can have some idea that the services are running and things are happening like it's supposed to. Then you can see Puppet pushes everything out to all the servers. And then we have basically a Nagios master server. It's just another Nagios server, but it only watches the other management servers. It's pretty much its only task. So he's actually the only one of all of these that's actually still on a VM, because he's only got 33 hosts to monitor. That's also our Splunk indexer. So all the logs from all the activity that happens anywhere all gets into Splunk, so we can do some kind of correlation sometimes, and we can follow the path of a host from the time that it gets set up in an operating system, gets monitoring added to it, all the alerts that it generates, to the time that it gets decommissioned. So especially if you're working with stuff that's in a test environment that may be having weird issues, we can kind of quickly see the whole gamut of where its life cycle has been. We're also running Cacti on our Nagios master, and his only goal is to watch the performance of the management servers. And I kind of went with that outside of Nagios, because I figured if Nagios was having performance issues, the graphs might get off and not be right. So we have Cacti using, it originally was using a CGI that it would talk to on all the management servers, and it would pull the data, but we found that just the overhead from that CGI check was just way too high. So I rewrote it to actually talk through live status to pull all the data. So now it has almost no impact when it runs, but it goes out and gathers all the basic metrics of the command pipes and the buffers and just kind of the core top half a dozen or so stats that you watch on the master for performance. Hardware versus VMware. One of the first things that when we kind of got a basic infrastructure running, we started looking at where were our bottlenecks, what was going to happen, where would we start hitting problems. One of the first things that we found is that our VM host couldn't handle more than about 1,000 or 1,200 hosts. It would start having issues. So we started doing a lot more in-depth performance analysis. And what we had found, we even got to the point where we had a brand new 32-core ESX server. We vMotioned our test box over to it, which was an 8-core, and we found that even that, it couldn't hold up to anywhere close to what a physical box could. Once we started throwing 1,000 hosts at it, 1,200. I think the next. So this was kind of some performance comparison numbers we went through. So I had the VMware box at first with either 4 and 8 processors and tried different numbers of hosts just to kind of see where our service latencies and the latencies. We were kind of shooting for less than 5 seconds is the high end for what we wanted for latencies. And we were seeing well over that on VMware. No matter what we really did, we got down to very few hosts before we could get the latency number down to what we thought was acceptable. We actually then got a loaner Power Edge, got to do some performance tests on that, and it held up much better. As you can see by the service latency, that even with roughly the same processors and same memory, it was night and day difference between the performance. We actually had, I think we had about 1,400 or 1,800 hosts in the test lab when we had the R710, and no matter what we threw at it, we couldn't get it to hardly change. So there's a huge difference in there. And then what was interesting, too, is the very last one was we had a whole bunch of these DL380 G4s that are like 8 to 10 years old. We started running some performance numbers on those, and you can see that even the latencies are way better than even what we saw on VMware with an 8-core. And so we kind of started digging in some more, and what we really found is that it seemed to be isolated to the high number of checks that were happening. Just the number of processes that would spawn up to do the check result analysis and the PNP graphing. Every time you forked another process, it seemed to put a pretty heavy load on VMware. So we kind of went back, and what we actually ended up using was a whole bunch of the DL380 G4s. They were laying all over the place, and, well, we've got them, we might as well use them, and if we need more, they're sitting on a pallet. So that's why, at this point, we have about 33 total management servers that do the load, because we figure if we run out, we just add another one. So what we kind of found is that when we were doing all the analysis, that the CPU requirements, it seemed like having more of them, so having large amounts of processors versus very large, powerful ones seemed to make a lot bigger difference. It seemed like it was able to adapt with all the spawning processes. We also found interesting, we thought we were going to use a lot more memory than we did, but most of the boxes either have 4 or 8 gig of RAM, and we're not hardly using any of it. The Nagios core in itself is really efficient. I think we've got 2 RAM disks set up now, each with 128 meg. I think one might be 64 yet. But other than that, we still have like a gig free of memory. So it's been pretty efficient, so that's been pretty nice. The disk I/O, I think kind of as we saw in the last presentation, that the faster the disks you have. We had a really hard time kind of doing analysis on this because there's no easy way to get a hard set number. CPU, you hit 100%, you know it's 100%, that's it. Where with disk and I/O, it's all dependent on your disk, your RAID cards, the cache. You can't really say exactly what's the maximum I can push. So we kind of set off is to see, okay, if the server's sitting there just kind of idling along, what do we normally see? And then when we see the spikes, trying to reduce those spikes down. So whatever the number is, let's just get it down as low as possible. So we moved as much as we could to the RAM disks. Right now, it's the status.dat, the object cache, and the check results are on one cache, and we separated off the P&P processing to another cache just because it was more fluid. Sometimes we would see spikes in the amount of data, or if P&P got a little behind for some reason, that data could pile up, and we didn't want that to affect any of the other processing that was going on. So we separated them into two different RAM disks just for kind of a safety reason. All of our servers are just running CentOS, RTL 5.6. We started upgrading some to 5.7. Basic stuff that I'm sure you guys all do, stripping down the running services, turning off anything that isn't needed. Yeah, so we actually create the RAM disks in the RC script during startup. We had a couple issues where the RAM disk didn't get created at the time that Nagios started, and then it started filling up disk because it was writing stuff out there. So I just put it directly in the RAM disk. So as soon as the RC script starts up, it goes out, checks for the RAM disk. If it's not there, it creates it, mounts it, gets it all ready, double checks all the permissions. So there's kind of a little bit of a snippet of the code that's coming out of the RC script. And enough people kind of asked for it. I threw it up on GitHub, so I've started putting some of my stuff up there. I can flip back to that address at the beginning too. So nothing too fancy. We didn't really have any problems with the U limits. Everything, but I've heard some people having a lot of issues where memory was limited or CPU cycle was limited, and they'd hit that limit. So usually I tell people you might want to double check what it is, make sure you're not hitting any of the U limits. We also did some re-nicing of some of the daemons and running services. We did this to, like the first line is what comes out of the Nagios RC script. We wanted to kind of make sure that the priority was lower on Nagios, so it had the highest priority of anything running out of the box. So something else didn't get the CPU, then it didn't get it. So you see like the perf data file command. So it's processing, the perf data. We lowered the priority on that. So we like to have the perf data, but we're not going to sacrifice Nagios' CPU time to do it. We also noticed one big spike that we had was coming from Puppet. Every time Puppet would kick off the factor command when it scoured the system to find info about your server, we noticed it was hitting pretty hard too. So we re-niced it down as low as we could. It doesn't seem to have any side effects, but it definitely curved that off, so Nagios now doesn't take a hit every time it runs. So we're currently using a pretty much stock install. We've had to apply a couple patches. My basic philosophy is I don't like to modify the code anywhere that I have to. I like using off-the-shelf stuff, so next time there's an update, I don't have to spend weeks doing lots of code testing and updates. We applied a couple patches, which I believe both of these are in 3.3.1 now. I know the first one is for sure. Allows you to have host groups that are created with absolutely nothing in them. And you can have services defined to those that do absolutely nothing. It allows us to roll out new servers. If we set up a brand new server that has nothing on it yet, the initial thing that Nagios would do is like, oh, you don't have services, you don't have this, you don't have that, and they would just die. Where this allows us, all we have is we have one host that gets created by default with a ping time of once a day. And that's enough to make Nagios happy to where he'll start up and nothing else has to be populated. We also have a patch against the command pipe that we found on some of our stuff where it was directly connecting to the pipe to send data. If you tried to submit data for a host that didn't exist, Nagios would just segfault. So that took us a while to figure that out because we'd be running and all of a sudden it would just be gone. And we're like, what? So we figured out where that was at, and that's helped a lot too. Yeah, because we ran into that problem when sometimes things would get pushed out on the client side. We'd start getting passive checks and stuff coming in for hosts that hadn't actually been set up on the management server yet. And so that would confuse things quite a bit. The large scale doc is pretty good. That's in the normal Nagios documentation. We followed that at first. We've had to change a few things. We rewrote the RC script to kind of optimize some of the restart times. We noticed that things like if the config was broken, it would go ahead and try to restart. Well, it shut it down and then couldn't restart it, so then your Nagios implementation was dead. So now I do a config check before it stops. So it has to pass that first. We also kind of reordered the caching, the pre-caching. So we'll do the verification. If pass verification, it'll do all the pre-caching, get that all ready. So the actual time to restart the server is a few seconds now. So I think it's right around 10 to 14 seconds. So the hit, whenever you get new updates and stuff, is pretty minimal. One of the other areas that I guess I kind of wanted to reinforce that's in the documentation too is the use of macros. We used to use a lot of macros for stuff just because it saved us time kind of templating things all over. Until we started doing some performance analysis of the core and started watching how it was running, we noticed that it was taking huge amounts of time and resources to do macro processing every time it ran something. So we've really stripped as many of the macros out except for the bare minimum. I mean, you kind of need host name is kind of an important one. But almost everything else for the paths and everything, we hard-coded everything wherever possible just because of that. We've kind of looked at doing some pre-caching on some of the macro stuff, but it's not something I've had time to finish, so that would kind of help if we could get that done. Okay. It's not working. I think it's the clicker. Sorry. I don't know what this thing is doing. Does anybody have any questions or comments so far? Anything they've seen or? Yeah. No, it looked like everything. I mean, it looked like when it was doing the macro processing, it was kind of global, that it was running through doing all the macro processing. So that's where most of them get written, so I kind of put that there. But those are the ones you can control the most. But, the things that are embedded in your service checks and stuff like host name, ARG, that kind of stuff, it's kind of hard to get rid of those. Yeah. Gotcha. Okay, cool. Yeah, because I think I might have talked with you on the list about that at one point. And it was one of those. Oh. Okay, good. Yeah, it was always kind of on my to-do list to kind of look at how to do that, but it's a myriad of other stuff that. Yeah. Okay, glad I didn't go down that path then. One of the other big performance hits we saw was actually with the CGIs. Every time somebody would hit refresh, and I know the documentation says, limit refresh times, but it still doesn't take away the fact that every time you hit the button, it still pegs the CPU on your box. So we've pretty much disabled the use of the CGI, so there's only a few people that actually have access to run them now. We strictly almost completely use live status and multi-site off of our Nagios master server. So it talks to all the other servers, finds out what's going on, and there's almost no overhead. Because we saw some pretty hefty spikes of 80, 85% CPU utilization, even if it was short windows while it was trying to pull all the info from the CGI. So, yeah, I can't be using that. Yeah, the network guys weren't too happy, too, when I told them to stop doing backups on my servers either. They were running system images every night, and then they were running TSM backups. And every time they did, you'd see the CPU spike and the disk I/O, and they'd peg it for a while, and then they were done. And so I just told them, I don't have a lot of important data that's not pushed by Puppet, so just stop doing it, and I'll rsync off what I need, and we'll go from there. So they weren't too happy about it at first, but it's worked out pretty well. Another big area that we saw is the logging level. And not from a disk I/O perspective. We saw it from a CPU perspective, that it seemed like any particular plugin that if we turned up the logging level, would suddenly the CPU would start to incrementally get higher and higher. Especially true if you were doing like the PNP debugging or obviously Nagios core debugging, but just the fact of turning those on would drive the CPU significantly higher. So that's one thing when we do see performance issues, we go back and look to make sure somebody hasn't turned something on for debugging. Comments is another interesting one. We noticed, and I think this is a lot of the side effect of multi-site and live status, the way it works, in that our ticketing system, when it acknowledges a problem, it puts a comment in for the host, which is nice. You can just hover over it and see what your ticket number is. The bad thing is if something goes wrong and you get a lot of tickets, you get a lot of comments. And if you get a lot of comments, the page starts getting slower and slower to refresh to the point where sometimes it won't refresh. So we have a script that runs, I believe it runs every hour, that will delete any comments that over X number. I think it's 10. So any host can't have more than 10 comments on it. It just keeps the last 10. Or if they're X number of days old, which I think is like 30 days. So if it gets more than 30 days old, probably don't really care at that point. Or if it's over, I think, 10. So that really keeps it down. Because we had some problems where a service that was having all sorts of issues that over time, you'd go to load a page, and it would like load half the page and then just stop, and we couldn't figure out why, and finally narrowed it down to the comments. Yeah, the last two are again, more stuff that's in the documentation, but felt that they were important enough that it's good to reiterate that these are things that hit us. Like I said, especially the macros. Yeah, it seemed like everywhere macros were done, we took a pretty good performance hit. So we've tried to just stop doing them anywhere possible. Some of the plugins we're using, the check NRPE, probably most people are using that for the Linux or Unix systems. Check log files, we use that on both Windows and Linux and Unix systems to monitor anything and everything in the logs. Some various hardware checks. The database checks. Check PS is kind of one that we rewrote it to collect data off the Linux boxes. So we get stats, but it doesn't actually alert on anything. All we're doing is we're using it to gather CPU stats. So it's kind of nice when you're seeing a high CPU load that you can quickly right below that see the graph for, oh, it was all I/O wait time, or it was all system time or user time. So we use it basically just for gathering data. That was one we had to kind of rewrite. It was an old script that had been around for a while, but I realized after doing some analysis of it, it didn't actually calculate process and memory right. So we had to kind of rewrite it to where it would actually gather. So if you wanted to say, I wanted to see all the Nagios processes, it will now gather all those stats and then run them through BC to calculate and actually get what the real values are for total. One that we kind of wrote too, this has been kind of helpful, is just an auto service command. I've been trying to kind of get this pushed out there, but haven't been successful so far. Probably same thing with you with lawyers. A pretty simple command. You feed it just what you want, and you say, okay, this service has to stay running. Under these conditions, just restart it. So it will, like let's say Puppet dies. It will go out there and say, oh, hey, yep, you're enabled. You're supposed to be running, and you're not. And kick it, make it go again. But usually I only do that for the first or second tries. So if it gets to the third try, and it will just give up and say, all right, I can't fix this. You're just going to send a ticket, and that's just the way it is. And one of our kind of, I guess, pet peeves is returning performance data. I think it helps when you're trying to troubleshoot stuff later. You do take a performance hit from actually collecting the data, but I think later on, when you're trying to see what's going on, it can be pretty helpful. And then we've got just a ton of custom plugins, like I'm sure most people do. So some of the other things that we've changed, NRPE, we did have to patch it to have a larger buffer size. We were just trying to collect too much data that would come back. NSCA, we've done the same sort of thing. We've needed to collect more data. We are looking at using the NRDP in the future. We need something that's going to hold up a little bit better. We also had problems with NSCA because we've got hosts all over the country, and we noticed that what would happen was we were losing a lot of messages, and we couldn't figure out where they were going. And what we found is that when they would come in, if the clock skew was off by a tiny bit, there's a patch. The native NSCA config will let you go back in time. So if it's a certain amount old, it'll process it, but it doesn't handle future. So if we got hosts that were even a couple minutes in the future, if their clocks were skewed, it would just drop their stuff. And with stuff being scattered all over the country and sometimes on lease lines, and you don't know what they are on sometimes, we ran into a big problem with that where a lot of stuff was being dropped. And it didn't take much. I mean, a second is all it would take, a second in the future, and you lose the data. So we wrote a patch for it that the standard option now works for past time or future time. So if you just put in max packet age of 60, it'll actually do 60 seconds in the past or in the future. So it gives us a little more flexibility. I think that just about eliminated all of them. We didn't want to do it completely because you will get some hosts that go off to Never Neverland and they'll come back and start submitting stuff that's 10 minutes old, 20 minutes old, or later, and you're like, I don't care by that point. One other big thing we ran into was the default NSCA RPM that has a XINetD config. There's no instances or per source lines in the file, which if you look at the man page says that means unlimited. We found that that's not really true. That unless you actually say unlimited, it's not. We started hitting a limit when we started initially rolling out. We started getting, I think it was in the order of about 10 to 12,000 messages. Was it an hour? And we found that was about the limit. It would start dropping messages after that it was too much. Once we changed those to actually be unlimited, last time we did a test of it, we were hitting just over 700,000 an hour. So huge difference. So we found that by that point, we're going to kill every downstream service from us if we actually start generating tickets like that. So I figured that was probably high enough. NS Client, we use that on all the Windows boxes. We have done some weird things to it, mostly because of internal weird requirements. Again, we had to increase the buffer sizes to be able to send more data. And we did have an issue where data that was way too big would actually just get dropped instead of truncated, so we kind of fixed that up. But I think we've talked about that issue. And PNP for Nagios, that's the other big one that we're using. We're using the very latest versions now, since we can actually get PHP 5.3 on all the systems. It's been a little bit nicer, and the interface is a little bit better. Performance is a little better, too. Some of the event brokers we use. We've sort of used DNX on and off. We haven't had a huge amount of active checks. We thought the number of active checks was going to be a bigger problem than what it was. So we've actually got the RPMs built and distributed everywhere, and all the configs are there, but we're not actually using a lot of it at this moment. It's more of a safety net to where if things do become an issue, we'll look at going that route. And the same for kind of Mod Gearman. We kind of want to, I guess, keep an eye out for what the technologies are out there. I honestly don't know a whole lot about it at this point, but it's been on my kind of to-do list to compare and contrast. The MK Live status, that's one that we use a lot. That's what Multisite actually uses to gather its data. It's an incredible event broker. We use it a lot for even just pulling data queries off our management servers, because you can gather anything that Nagios knows. There's if you print off the whole list of all the data, it's like 12 or 18 pages of data that you can collect. Everything you want to know about a host, a service, the logs, comments, anything you can get from there. And it's kind of like an SQL sort of language. and it has almost no impact on the server. So you can query it and say, give me all the hosts that are in this host group, and it'll just return them like that. Very little overhead. Yeah. Of the Nagios server itself? Wow. No, I haven't. Yeah. That's the one bad side effect of event brokers, that if something goes wrong, it can go really wrong really fast. It can take everything down. So yeah, that's probably one of my more favorite ones, because we use it in a lot of our stuff to pull data. We have a performance data one that we wrote that will actually take any incoming performance data and just open a socket over to Splunk and just dump it all over. We did it that way rather than using the NDO utils, because Splunk was doing a little bit better job of doing some capacity planning stuff for us. But also, this was a lot less overhead. There's a very small timeout on the connection, so if it doesn't connect right away and get the data off, it just drops it. There's a potential we lose data, but it's all centered around keeping Nagios at the core running and running well. So we're willing to sacrifice some of the data to keep it running. One of the other big thing we noticed is we had some background jobs that we were always looking for data out of the logs. It's, show me these sets of hosts, or show me this data. And we noticed that every time we hit that Nagios.log with a grep, it'd drive the CPU through the roof again. So what we actually started doing is we wrote this event broker. It's basically a log separator. It looks for the certain messages we're looking for and puts them in their own logs. Outside of the Nagios log. We rotate them fairly often. But the big reason is then when we need that data, we can just cat the file and dump it. We don't have to grep through stuff, and it just almost completely eliminated all the overhead. Because if you can imagine that all of the data and the checks that we have coming in, the logs by the end of the night, right before it rotates, we're getting huge. So we'd see these CPU spikes throughout the day, getting larger and larger and larger and larger, and it was always when the greps run. Some other stuff we're using, Puppet. Puppet manages everything. We can take a raw machine, set it up, and say, you're now a Nagios server, and within 20 minutes he'll have all the software, all the configs, everything he needs. So it's really been a lifesaver for us. That's what also makes some of our management harder, because we're managing the config files all within Puppet itself. So when we're manipulating config files, you have to know which server that box is actually on. So the tool that we wrote has to have some intelligence of where to find that in the Puppet directories at. I guess the Graylog 2 and the Splunk kind of go together. I've got Splunk, and it's been great being able to set just massive queries to look for anomalies. So when we can see weird things coming in, checks coming in for hosts that don't exist or services that don't exist yet, finding all these little issues and what's going on. But the only thing I haven't liked is it's expensive. We're running probably 20 to 25 gig a day, which is a pretty hefty license, even with as many licenses as we do have. The Nagios environment actually generates more logging data than all of the web services combined on a daily basis. It's just the massive amount of data that it gathers per day is kind of mind-boggling. Cacti, as I said before, we're using that with the Nagios stats template just to pull all basically the Nagios stats data, using over to live status so we don't have the CPU hit. Our custom control panel we've talked about. And Console Labs, we've got a lot of their stuff. A lot of their stuff has been very helpful, like the check HPASM, check log files. So there's been a lot of good stuff that they put out. Some of the things that I guess I've used to watch our system to find out what's going on, VMstat, IOstat, top, IPtraf, SAR, strace, ESXtop. isn't as helpful because we kind of moved off the VMs for most stuff, but can be kind of helpful if you're still on a VM. Yeah, so varying degrees. Like I said, I'm not going to go through the details of all the tools because like I said, we could spend probably a week just doing that. But all of them kind of address different areas and different stuff. Some general config notes. Yeah, the way we did our host config files is we kind of wanted things to be templated. So a host has everything that host needs. When you want to add a new host, we add a config file that has everything about that host. What we've actually done is we have services are tied to a service group. Service groups are then tied to a host group. So then we can basically just take a host file and say, here's this file, and he's in these host groups, which then will suck in all the services that he needs, and when you want to get rid of a host, you just delete that file and you're done. So it makes the management of the host a lot easier. If you want to start doing fine-grained controls of this service does something different on this host, that's when things start to get a little more tricky. So it's kind of been a balance of easy management versus a lot of the controls. So yeah, I guess it kind of shows how we've kind of tied stuff together. Yeah, everything built from the control panel. We also do the parent building automatically at the time we set up hosts. We're kind of lucky that we actually have a team that all they do is like scour the network and find out what's connected to what. So I get a daily data feed from them as to what's connected to what, so I can just say, okay, I have this host. Is he still associated with this switch or this router, to make sure that parent-child relationship is still there? Because that was a huge win for us that like HP OpenView, which is what we're migrating away from, has no concept of this. So when a node goes down, it's even worse than that. When an OVO agent stops responding, it says the node's down. And it could be just the agent's gone south or the agent's died and it doesn't know the difference. So the fact that it actually can tell the difference between the agent being down, the host being down, and when the network is down, reduced a lot of false positives for us to be able to tell kind of exactly where stuff happens. Where that gets to be a problem is on like some of the ESX servers where they're vMotioning stuff around all over the place that you may not exactly know where it is. That's a little bit special case. What I've actually done in that case is actually have a script that it runs a recon every hour against the ESX servers and says, hey, tell me everything you know, and then it matches what we have and say, all right, well, if that's still true, then don't do anything. Otherwise, rebuild the host file and kick Nagios. So we kind of handle that on one server specifically to keep that updated. So yeah, our parents, when we're doing the pings, the parent devices, what we've set them up as, rather than we don't want to take a hit from monitoring them all the time, when most of the time we don't really care unless the other one's down. So we used a very simple fping, and it's set to only ping it once a day. So normally he doesn't do anything. There's no traffic. It's just that if the host looks like it's down, he'll start to ping the parents. And we try to use event handlers as much as possible. So we try to automate everything possible that if the service goes down, try to restart it. If you find some anomaly, try to fix it. That's been a big push, is to just make it as automated and self-healing as possible. So even like Nagios will restart Puppet to make sure it's all working well. Puppet will also restart Nagios to make sure that it's working. So put all sorts of dependencies on each other to try to make sure it all works. Some of the things that we're monitoring, I think a lot of these are probably pretty basic stuff. Yeah, the CPU, memory, basic services, ports being open. NTP drift is an interesting one. We saw some, when we started seeing the NSCA errors, we started watching the NTP drift to see how bad it really got. And it's interesting when you watch it, it's kind of a funny wave. And I didn't expect NTP to drift that much, but it seems to. We actually have a Nagios config test that also runs, I think it's once an hour. So one of the problems we ran into, since Nagios won't restart itself if it's broken, we found out that sometimes things were broken and we never knew it. So things would get pushed out there and Nagios just wouldn't restart it, just happily keep going, but yet hosts wouldn't show up and services wouldn't change. We're like, what's going on? So we actually added a check to actually run a config test just to validate that there were no errors, there's no warnings, and it actually is running like it's supposed to. we have to monitor the P&P directory size. We kind of have a threshold for, all we do is just simply watch how many files are in that directory, because we noticed when it started getting behind, they'd pile up. So we have a pretty low threshold. I think it's like five files in the file will generate a warning. So if it's getting more than 5 files behind, we've got an issue somewhere. We do some specific performances on specific processes, like the Nagios process itself and some of the core supporting stuff. And this has been kind of helpful for things that are a lot more dynamic and doing stuff, like our integration to our ticketing system is a constant running daemon. And we found some weird memory leaks in it under weird certain circumstances. So we've kind of put just some performance of CPU and memory on certain processes so we can kind of get an idea over time how much they use and what they do. Puppet was another one that we had seen from time to time would just stop. Some cases would be as if there was a lock file that wouldn't get removed, and so Puppet would restart, but wouldn't actually do anything because it thought it was already running. So what we have it do is we have it every time it actually runs and starts to do something, it touches a file, and we just monitor that file age. And if it gets more than an hour old, since, well, it's 3 hours. I think it's 3 hours. Since Puppet's supposed to run every hour, I think we did if it's at 3 hours, generate a warning, and if it's the first time it hits a warning, it actually tries to kick the Puppet service and clear the lock if it's possible. And that's taking care of most of it. It doesn't happen often, but once in a while. And we figured, well, Puppet's kind of the key to making sure everything stays the same and synchronized. It's a pretty important one. Database response times. Watching, well, 3 different types of databases depending on what the service is. A lot of it just watching response times, make sure they're actually responding so we can actually push updates and pull stuff from them. General Apache stats, bunch of custom apps that we have watching all sorts of stuff, making sure user accounts that are created are supposed to be. Most of our SNMP and WMI stuff is mostly related to network stats. We don't use SNMP for a lot of other stuff. It's just we've had some issues with it, especially like processes. If you're trying to monitor a process, you don't always get all the attributes that a process is running. So if you're trying to monitor, like, say, a Tomcat process, okay, well, somewhere buried in that huge, long Java screen is the name of the Tomcat, and if you try to pull it from SNMP, you'll see that it's Java's running. Not overly helpful. So put some links to some of the stuff we've been using, so we can kind of see where to get most of this stuff. Well, the live status slave, I guess, is one I didn't really talk about. It's kind of another add-on from somebody else that it's actually like a web service interface into live status. Yeah. I think all of these are going to be posted somewhere, aren't they? Yeah. Yep. 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 Yeah, that's why I put all this here. That way, if anybody wants to find stuff. But yeah, the live status is kind of cool because it's the same interface to live status, but it does it as a web service. It's a PHP script, but it returns JSON. So we can have, like, our custom control panel can now query and very easily pull data right out of live status on hosts. That one's been pretty handy. Our web guys have really liked that. So I guess that's any other questions, or I said I wasn't really sure what to put in and what people needed, so.
I noticed when you were mentioning the birth data.pl. Are you guys look at doing the bulk processing of the birth data?
Yeah, we've tried a bunch of different options to see which would actually work better, and that gave us the most control over performance, because you could re-nice it and change what it does. With the bulk processing, you kind of lose some control of it. So this I kind of liked a little bit better, and it seemed to have evened out. We had a lot of problems before where we'd start getting gaps in data, and that giving it a real low priority and then just letting it chunk through seems to have made it happy. So it, if it was trying to do a high priority and it couldn't get the CPU, it would either kill one thing or the other. And so, yeah. Yeah.
Let me give you this microphone here. How we can get that on the recording.
Thanks. You'd mentioned that you were automatically adding a comment with the ticket number from your ticketing system. I'm assuming you're using live status for that?
No, that's actually coming back in through. it's coming back through another interface that we have that's in with the ticketing system. The system that it actually goes out, talks to the ticketing system, and it kind of just sits and spins and waits for the ticketing system to come back with a number, and then it automatically adds it right back in through the command pipe.
The command pipe, okay.
Yeah.
Through a custom tool you use to submit tickets.
Yeah, it's interfacing with HP Service Manager.
You too. My condolences.
Yes.
Yeah, yeah.
Yes.
All right.
It's been a necessary evil. It works most of the time.
It's a nasty beast.
Yeah, and we also, as soon as it gets a ticket number back, it acts everything. And so we've had issues where when it goes south, it kind of makes it nice because then our support people, they know, okay, Service Manager's down, they can go in into multi-site and then see, oh, well, this one isn't acknowledged, this one isn't acknowledged. They can see exactly what hasn't been handled yet.
Okay.
So
I don't suppose you might consider sharing that script. We're looking at doing the exact same thing.
I can try.
Cool.
There might be a way.
Yeah, nice.
So,
Thanks.
Yeah. Anything else? Anything you guys would like to see more of? Yeah.
I'm just curious, what are the pet peeves that you have with Nagios, and how would you like the things that you would love not to have to build around? If you could just put them up briefly, or you can email them to me later. But a nice recap would be good, so you can get off the top of your head.
Yeah. For the most part, everything works pretty well. The only thing I think I've been kind of annoyed with is kind of the NRPE, NSCA whole data transfer. It seems like the whole thing would work better with some kind of messaging queue. It seems like we've had to kind of patch things and, trying to stuff things in and out of it. It works really good for command and control, but you try to start passing large amounts of data back and forth and it just kind of falls over. And that's probably been my biggest annoyance. And probably having to restart the server every time I add a host. Live adding of hosts would be great because we do that constantly. It seems like that's one of those things that you could, inject it right in and tell it to reread the config files. But if I remember right, what we ran into is if config files are there, when you do a reload, it'll refresh those. But if it's a new config file, then it won't actually pick up on it. So every hour, potentially, we have to restart Nagios to pick up new configs. So while we've got the process down pretty close, it's still kind of annoying. But, yeah.
So if you're having performance issues with the NSCA, there's actually a patch in the developers list from last month to circumvent the command pipe and dump it straight into your check result directory.
Our performance was more in the number of connections it would take. We actually started running it through XINetD on purpose. We actually got better performance numbers. I could spawn them faster. XINetD seemed to perform a little bit better buffering for us.
Do you cache your NSCA connections, or you do one per service?
Just one per service.
I very recommend just a 2-second cache, and because NSCA will handle more than one service per connection if you pipe it all through.
I don't remember if we looked at that at all. I'll have to go back and look again. Yeah, that might be helpful. A lot of our stuff is just so many weird things coming from so many different places that this host will send one message and then, and that was one of the big things we also noticed too that I don't think I put on here was we had noticed one problem with NSCA and lots of passive checks because we run probably, all of our Linux boxes are pretty much all active, but most of our Windows servers, probably 2/3 of the checks at least are passive. And what we had noticed is huge CPU spikes, like every 5 minutes when NSCA would send its data back. And because of the nature of, having everything automated and pushed, times as to when things would happen became very consistent across all of our servers. So it was almost every 5 minutes. So on some of our scripts that send data back, we had to purposely put in some small wait statements, and they were random. So it'll randomly wait sometime between now and up to 60 seconds and then send its data, just so it wasn't killing our server every 5 minutes, and then the server would be idle for the next 4.
Yeah, I found that the 2-second cache for NSCA it got rid of a lot of network latency.
Interesting. Yeah, I'll have to look at that. It'll be good. Yeah, and if anybody else has any of the stuff they've run across, that was one of my big issues when I first started, is just finding other people that had any kind of real sizable install as to what have you done, what have you not done. So a lot of it's just been trial and error. Try this and see what happens. And yeah.
So you talked a lot about how to get Nagios to scale to that many services. What about your consumers in the company of the data? Do you have a lot of contacts? Are you sending a lot of alerts?
Not as many as you would think. It does a lot of verification to make sure that we're not sending false alarms. You know, we've adjusted retry times and stuff like that, and because so we have a lot of servers that sit out on weird latency links, and you never know what you're going to get. So we've tried everything we can to reduce false alarms to a minimum. Flapping services is one that's kind of hard to control, but no, it's actually it's surprising that I don't know that I know counts off the top of my head, but I know when we were doing the initial implementation, we were comparing tickets that OVO would cut versus what Nagios was cutting. We would compare them, and Nagios was almost always less, just inherently because it understood parent-child relationships, node down. It understood the environment better, so it would inherently cut less tickets, sometimes by as much as 2/3 than OVO. So, but it's good. I should see what our actual ticket numbers are like that size.
Anybody got one more question?